Hello guys. Today we are going to talk about the James Webb Telescope. Okay, let's go. For millennia, humanity has battled with key questions about the origins of the universe, and whether there is life on other planets. We have observed some signs of the possibility of life, and if this leads to findings that there is other life, that will be an incredible discovery. If, however, we are alone in this university, our response can only be one of awe. That we exist alone in this universe will surely be a miracle. Webb will allow us to answer these crucial questions, and in so doing, its results will, regardless of the answer, be revolutionary. Webb makes it possible for us to ask these questions in ways that were just impossible in the past. That suggests that scientists will shift a large degree of their focus to these questions, given the wealth of evidence that is likely to arise from Webb. Nelson said that, "We are going to be able to answer questions that we don't even know what the questions are yet." Webb is the defining scientific instrument of our age, and signals an enormous shift in the direction of science. What is the James Webb Space Telescope? The James Webb Space Telescope is the world's largest and most powerful space-based optical telescope. Whereas its predecessor, the Hubble Space Telescope, circled the Earth, the James Webb Space Telescope orbits the Sun. Its mission is to conduct infrared astronomy, and it will enable scientists to view the world as it was 200 million years after the Big Bang. In doing that, it will take pictures of some of our universe's first galaxies. In addition, it will observe objects in our solar systems beyond Mars, see through dust clouds to see any stars and planets forming inside them, and hunt for signs of life on other planets. Webb's enhanced infrared resolution and sensitivity gives it a power to see further, and more clearly, than Hubble was able to. Researchers believe that Webb will allow them to probe a number of astronomical and cosmological problems, such as observing the first stars, the formation of the first galaxies, and the detailed atmospheric characterization of potentially habitable exoplanets. NASA led Webb's development along with the European Space Agency, ESA, and the Canadian Space Agency, CSA. Through its Goddard Space Flight Center, GSFC, in Maryland, NASA managed the development of the telescope. Webb is operated by the Space Telescope Science Institute in Baltimore on the Homewood campus of Johns Hopkins University. The prime contractor for the project was Northrop Grumman. The Space Observatory was named after James E. Webb, who was the administrator of NASA between 1961 and 1968, when NASA deployed its famous Mercury, Gemini, and Apollo programs. Images such as this will help us understand how the first stars and galaxies formed. Some of these may be among the most distant objects known, from the beginning of the universe. The picture is a composite color image made from observations made at different wavelengths. It was taken by the telescope's near-infrared camera, NIRCam. SMACS 0723. NASA, ESA, CSA, and STSCI. James Webb has also caught a glimpse of Stephan's Quintet, a group of 5 galaxies that are merging some 290 million light-years away in the constellation Pegasus. The image also suggests there's a supermassive black hole at the center, and shows stars being born. The data will tell us more about how galaxies evolve and the rate at which supermassive black holes grow. Stephan's Quintet. NASA, ESA, CSA, and STSCI. The next picture shows the Carina Nebula, seen in the image below, which is one of the largest and brightest nebulas, clouds of dust and gas in which stars are born. James Webb can probe deep inside dust in the infrared light, to reveal the inside of the stellar nursery, which we've never seen before, to discover more about how stars are born. The Carina Nebula is located approximately 7,600 light-years away in the southern constellation Carina. The image shows hundreds of completely new stars. Every dot of light is a star, and jets and bubbles created by them. We can also see details that we cannot yet explain. A star-forming region in the Milky Way. NASA, ESA, CSA, and STSCI. The next spectacular image is of the Southern Ring or 8-burst nebula, a planetary nebula, which is an expanding cloud of gas surrounding a dying star, or in this case 2 dying stars orbiting each other. It is nearly half a light-year in diameter and is located approximately 2,000 light-years away from Earth. The foamy orange shell in the image is molecular hydrogen, a gas which forms when 2 hydrogen atoms bond together, whereas the blue center is an electrically charged gas. In the right-hand image, you can see the 2 dying stars in the center, giving us an opportunity to study stellar death in unprecedented detail. Southern Ring Nebula. NASA, ESA, CSA, and STSCI. The new data is the result of months of painstaking measurement and testing to make the James Webb ready for use as a scientific tool following deployment. The first steps were to focus and align the images of each of the mirror segments. Each of the telescope's scientific instruments, NIRCam, the Near-Infrared Spectrograph, NIR-SPEC, and Mid-Infrared Instrument, MIRI, were also switched on and tested. All these instruments, which look at deep space in different wavelengths, had to be cooled down, along with the telescope, otherwise they would radiate background heat which would interfere with the sensitive observations of astronomical objects. The last to be turned on was MIRI, which operates at the lowest temperature, just 7 degrees above absolute zero, which took several months to achieve. The size of a telescope, its aperture, is the key thing that decides the ultimate quality of the images and the detail that can be observed. Bigger is better. Large telescopes with apertures up to 10 meters in diameter have been constructed on the ground. However, the interfering effects of the atmosphere, which disturb the light reaching the telescope, make it hard to achieve the ultimate resolution. Also, on Earth, background light from the night sky limits the telescope's sensitivity, the faintest objects we can see. With its 6-meter aperture, James Webb is the largest telescope ever launched into space, and from its vantage point a million miles from Earth, free from the Earth's atmosphere, it is expected to deliver the best, most detailed views of the universe we have ever seen. There is no doubt that it will revolutionize our understanding of the cosmos, just as its predecessor, the Hubble Space Telescope, once did. The Cartwheel Galaxy is located roughly 500 million light-years away from us. That's a massive distance. As such, having an instrument that can zoom in on such an entity with so much detail is astounding. And that's exactly what the James Webb has done. This new video from the ESA isn't just dazzling. It's also a great indicator of the James Webb Telescope's scope, and what it's capable of. Since the James Webb hit its destination and began testing, we've known that it was going to do great things. However, the new space telescope has done even better than NASA expected. So well, that NASA says it's still performing better than expected even after taking irreparable damage. It's already captured some of the most iconic images we've ever seen, and it's just getting started. The Cartwheel Galaxy Image Source. NASA, ESA, CSA, STSCI. Understanding James Webb's full scope is important because it helps define how impossible images of galaxies like the Cartwheel Galaxy would be without it. Not only is seeing these galaxies inspiring, but it also allows us more insight into these kinds of celestial entities. Other data gathered by Webb has allowed scientists to determine that a planet also had water in its atmosphere. But the Cartwheel Galaxy is just one of many intriguing pieces of the puzzle that is our universe. This galaxy is currently in a transition phase, so we're not sure where it will end once the colliding gases slow and finally settle. For now, though, it looks like a beautifully designed wagon wheel. And, as James Webb continues to look deeper into the universe, we'll undoubtedly discover more about galaxies like it. For now, though, having a better understanding of the James Webb scope is going to make the jobs astronomers have to do much easier. Okay guys, this is the end. Click like and subscribe. Goodbye.